Dear students, greetings from Dr. T. Sindil Murugan, Associate Professor and Head, Department of Information Technology, Kakatiya Institute of Technology and Science, Warangal. In this video lecture, we are going to discuss about classifications of data structure. Already we have discussed what is data structure, what are the basic entities of the data structure in previous video. In this video, we are going to discuss about classifications of data structure. This is self-learning topic 1, classifications of data structure. So before starting the lecture, we must be discussed about the course outcome, like lecture outcome. After completion of this lecture, student will be able to classify the data structures. What is data structure? Data structure is managing data. Okay, so especially we have two textbook we are following. One is Rima Raja using data structure using C. Another one is classic data structure by Samantha. So these two books are considered data structure is a crucial part in data management. So data structure is basically group of data element that put together under one name. So example, student name list. Okay, so roll number, serial number, name, and many details will be collected together, and we are simply saying one name, that is the data structure. It should be in the proper order, and how we are stored this data in the computer, that will be belongs to data structure. A data structure is classified into two broad categories, like a primitive data structure and non-primitive data structure. Primitive data structure, what is a primitive? Already the user, built-in data types. Already we know that in programming languages, some data types are used as a built-in data types. Those data types are considered as the primitive data types. Okay. So non-primitive data structure, what is non-primitive data structure? It is defined by the user. Okay, it is not already built in the programming language. It is built by the user or developer or programmer. So what are the classifications are there? Primitive data structure means already we know integer type of data is considered as the integer. Float types of data considered as a float. And character type and string type will be considered as a character. And pointer is used for pointing to the particular location. So these are the primitive data structure we know. So non-primitive data structure. What are the non-primitive data structure? Non-primitive data structure means it's a user-defined data structure, arrays, list, and files. Okay. So already we discussed in the problem solving using programming subject. So this concept already we have idea what is an array, how the array is working, and what is list, what are the types of list, and what is file, how to access the files, what are the operations of files. Those things we are discussed in the previous semester. In this semester, we concentrate about this entire non-primitive data structure, how it is working. In list, again, it will be classified into linear list and non-linear list. Okay. So linear list have stack and queues, and non-linear list have graphs and trees. What is linear list? First, we must be know what is primitive. Primitive, I already told, it's a fundamental data types which are already supporting the programming languages. Non-primitive means those data structures which are created using primitive data structures. Okay, so we know that here we are using primitive data types. Based on the primitive data types, when the user is creating another data type, that is considered as non-primitive data types. It is classified, again it is classified into linear and non-linear data structure. What is linear data structure? Linear means the memory allocation. Data structure means I already told, organizing the data as well as storing the data. How the data are stored in the memory? If it is sequential manner, it is stored. Okay, so what I said, continuously it is stored, then it is considered as a linear data structure. Okay, so it is single level is involved. So that means we can traverse all the element in single run only. If example array, so A of 5 is there. Okay, so how we can allocate the memory? The memory will be allocated from continuously with indexes of 0 to n minus 1. Okay, so already we discussed many times The memory will be allocated continuously, and it's how the indexing with 0 to n minus 1. Okay. So same like that, the data, wherever the data is stored in a linear or sequential manner, that is considered as a linear data structure. So examples we can say array, stack, queue, linked list, and many things. So the basic thing is how the memory is allocated for the data. That is the linear data structure. Non-linear data structure. What is non-linear data structure? So it is not arranged sequentially. First thing, it is not in a continuous manner or sequential manner. Okay, wherever the spaces is there, accordingly it will be there. But the main example for this is tree and graphs. What is tree? So previously we have linear data structure. So we know that array, stack. What is stack? Stack also using array we can represent. Okay, so there is a pointer is there. So the pointer is pointing to position of top. The top value will be filled. Like it is considered that like water tank. You just consider if water we are putting, it will be stored from bottom and it will be removed from top. Like that we consider. So top pointer is pointing to the current location of the memory. In top position only we are adding the elements into the stack. If you want to remove also, we can remove from top only. Okay, so that concept we will study later. And queue is means again first in first out order. Okay, so the memory will be allocated like this. If any any data we want to add means that will be added in the last position. If you want to remove means from the first position. Okay, so that's why we saying FIFO. This first in first out. Who will come inside first, that will be removed first. Okay, so like that, it's having FIFO order. And linked list. Linked list means the data considers a node. Each node have data part and link part. So this will be linked to another data where it is stored. Okay. So that another link will be pointing to next where the data is stored. Like that, the list is created. This is considered as a linked list. Okay. In non-linear, trees and graphs are there. Data are not shared. Trees means hierarchical structure will be there. Okay. So root node, parent node, or child nodes. Child nodes have again child nodes. So if this node we are considered, this is the root node or parent node. Okay, root node. Each root node have some parents nodes. The parent node have the children's nodes. So like that we can consider if it is following the hierarchical structure, that is considered the tree. Graph means again we know that vertices and connecting edges are there. Okay, so for example, nodes are there. The circle may represent the nodes. We can connect with the nodes are considered as the vertices. Okay, so the links are considered as the edges. So combinations of nodes and edges are considered as the graphs. Okay, so these graph structures are considered as the non-linear data structures. So we will see some differences between linear and non-linear. Okay. So linear means arranged in a linear order. Okay. So the data are stored in a sequential manner. But in non-linear data structure, it is hierarchy manner. Okay. So the linear data structure, single level is involved. Single level means we know that the data are stored continuously. In a single run, we can access all the elements. But here in tree and graphs, it's not like that. Okay, so it will have multi-level are involved. Implementation also, when we are compared with non-linear, linear is very easy. But when we are implement the nonlinear data structure is a little complex while comparing with the linear data structures. Okay, and then if you want to perform traversal operation, what is traversal? Traversal means we have to visit all the nodes at least once. If 5 nodes are there means each 5 nodes will be accessed at least once. So that is very easy. But in multi-directional non-linear method, it is very difficult. Okay. And memory is not utilized in an efficient way. So that means memory will be continuously allocated. For example, A of 10 we are creating means 10 memory will be allocated. First 10 indeed. If int A of 10 means 10 2 bytes will be allocated. If we used only 2, 3 integer values, remaining are free means we are not utilized properly. But here memory is utilized in a efficient way. Wherever the free memory is there, that will be allocated. Okay. So there is a link, indexes, many things is there that we will discuss in the last unit. Okay. So examples here: array, stack, queue, linked list. So these are the linear data structure. Trees and graphs are considered as the non-linear data structure. Okay. So applications of linear data structure we have used in the application software development. Example, stack queue applications are there. No, those are the applications of linear data structure. Non-linear data structure mainly used for artificial intelligence image processing. Like if example Google Map is there, Google Map will work based on the graphs. Okay. So these are the non-linear data structure we can say. So now we are in the end of the video lecture. Having completed the discussion on classifications of data structure, the student will be able to classify the data structures. So now you know which is array, which is tree, which is graph, and what way we have to use that, and which is the list. List means what is the linked list. So those things we know that we will discuss one by one in the further videos. Okay. So further doubt you can refer the Rimata Reja textbook. Chapter 2, 2.2 classifications of data structure. I hope you are enjoyed this video as well as you understood what is the classifications of data structure. Further doubt, you will come with the doubt we will discuss in the classroom discussion topic. Thank you very much.